In this example, we're given that triangle ABC is similar to triangle XYZ. We're also given that side AC is 5 centimeters. And we're asked to find the length of side XZ. We're also given that the area of triangle ABC is 24 centimeters squared and that the area of the similar triangle XYZ is 45 centimeters squared. First step you're going to want to do is sketch the two similar triangles. Now looking at the areas of these triangles, you should recognize that triangle ABC is the smaller of the two triangles. So we've identified that area as being 24 centimeters squared, and this one is 45 centimeters squared, and now we'll go ahead and label each of the vertices of the triangles. We also know that in triangle ABC, that side AC is 5 centimeters, right here. And remember that we're asked to find out the length of side XZ, and we'll call that Y because it's across from angle Y or vertex Y, so we'll call it little y. Now remember that AC and XZ are the corresponding sides, and therefore we can write their ratio as being AC over XZ, or if we sub in the values that we know according to the illustration, that's 5 over Y. Since these triangles are similar, we know that the ratio of their areas is equal to the square of the ratios of their corresponding sides. So we'll set up this ratio. The ratio of the area of triangle ABC to triangle XYZ, we know is going to be the square of the ratio of the corresponding sides. Now we know that the ratio of the corresponding sides from up above is 5 over Y. So we need to square those values, 5 squared and Y squared, which we can simplify to be 25 over Y squared. However, in this question we also know that the two areas of the triangles are given as 24 centimeters squared and 45 centimeters squared. So that arrow shows that we can substitute in an area of 24 centimeters squared for the area of triangle ABC, and for triangle XYZ we can sub in 45 centimeters squared. And our proportion looks something like this. Now, to try and figure out what y is, what we need to do is perform the procedure of cross multiplying. So we'll multiply those two values followed by those two, and it looks something like this. 24 times y squared is 24y squared, and 45 times 25 looks like this. We'll simplify this a bit. 25 times 45 is 1,125. And now to get y squared all by itself, you need to divide both sides by 24. Looks like that. And we can go ahead and solve for y squared. So 1,125 divided by 24 will give us 46.875. Now, to get y all by itself, we need to reverse this squaring process, which means we need to take the square root of both sides of this equation. Now remember that there's always a positive and a negative square root. In this case, we're going to take a look at the positive square root because we know that it's a length, and the length can't be negative. So when we take the square root of y squared, we get y. And when we take the square root of 46.875, we get approximately 6.85. And we can extract now that the length of side y, which we know was xz in our diagram, is approximately 6.85 centimeters.